announcement today by George of the 96 boards, I went running upstairs to change this. So this is not a stock presentation I do at all, but I'll tell you it has been highly influenced by what happened today. This is the second computer I ever programmed. It was a PDP-8. It had a very elegant and simple instruction set. There was only 8 instructions in the entire instruction set. One of those was used to do a multitude of things like shifting the registers right and left. It had one register. All of the data and all of the instructions were exactly the same length, 12 bits. And so it made it a very easy thing to program in assembly language. I had learned Fortran before that, and I was programming this in assembly language. Nobody told me that assembly language was hard, and so I just picked up a book and learned and taught it myself. Now, at that time,
What's your, just curious, what's your first computer?
I'm sorry, what is what?
What's your first computer?
My first computer was an IBM 1130 computer that I programmed in Fortran in 1969. I learned to program that through a correspondence course. But I also joined the Digital Equipment Corporation User Society. And this was a group of people who were trying to use computers. Back in those days, there was no such thing as a professional programmer. If you were a programmer, you were typically a physicist or an electrical engineer, or you were a mathematician, or you were trying to do some type of business and you needed something to be done, but nobody really wrote software for other people. You wrote software for yourself. And therefore, when you were finished with the software, you said, what am I going to do with this? Because as you know, selling software is very difficult. You have to document it, you have to provide support for it and other things. So these people contributed their code to the DECUS library, which would then make copies of it and sell it to you for the price of making the copy on paper tape. $5 for a paper tape that contains something like a text editor, and $15 for a paper tape that contains something like an assembler. But they exchanged their data and their information in source code, and they met at DECUS meetings to collaborate and share their ideas and their programming, much like we're doing here at Connect. Now, at one of these DECUS meetings in May of 1994, I met Linus Torvalds, and I saw Linux for the first time. And at that time, Digital had come out with their Alpha computer, which was a 64-bit computer, microprocessor. And for a large number of years, it was the fastest microprocessor in the world, according to the people who keep records on those things. It was a RISC processor, much like the ARM is a RISC processor. And when I saw Linux, I convinced him to take this 32-bit Intel-based operating system and convert it into a 64-bit RISC-based system. Number one, to try and get the Intel-isms out of it, because programmers, being like everybody else, if they see a way of making something better and faster by taking advantage of a specific thing in the architecture, they might. And also to allow it to address a lot more data. And a lot of times we say 64 bits, but we don't even really comprehend how big that is. That's the same thing as filling up a 1 gigabyte disk every second of the day, every day of the year, for the next 5,386 years. It's a lot of data. And I convinced him to do it. We created a small community of people inside of DEC. We had about 5 or 6 engineers, and David Rustling was one of them. And then we found the strength of the community in doing this port. And as I go through this talk, I'll talk about some of those community people and what they did. Now we're going to fast forward a little bit to modern day Linux and some other people things I'll be talking about. I typically show this slide at a lot of my talks where I talk about free software and open source. And these are people who probably would not have been able to do the things they did, and particularly at the age they did, if they'd been using closed source software. The person in the upper right-hand corner, his name is Eric Troen. He joined together with 2 other people to start a little company called Red Hat Software. They were university students, and they decided to make a distribution that was easy to use. And from that, Eric became a multi-millionaire. He then went on to start RPath, another company, which was dealing with free software and development tools. The person right here was starting a small consulting company out of his university room, and he decided that he needed a PBX system to be able to communicate with all the other people that he was trying to bring into his little support company. But he found out that the PBX was going to cost between $20,000 and $30,000. And since he didn't have that money, he decided to write his own. And he did. And he calls it Asterisk. And today, the Digium company supports or employs about 350 people, with thousands more around the world installing Asterisk PBX systems. And Mark Spencer is a multimillionaire. This guy is not a multimillionaire. He's from Soweto, South Africa. It's a very poor community just outside of Johannesburg, about 500,000 people. I know him because he was helping Linus Torvalds debug a problem in the AMD memory subsystem of Linux using dial-up networking, which is the only networking he had. And he had taught himself everything about computer science. I won't go over the other people, but about 2 years ago I went to Colombia and I saw a bunch of kids there using Arduinos and then later on Raspberry Pis to do home automation, including this young man right here who had built an entire house complete with tiny little paintings that his mother had painted, and he was controlling this with an Android tablet, turning the lights on and off and everything in the house. He was 17 years old, and today he has his own company making home automation systems. Of course, there's many little of these ARM computers these days, and you probably are familiar with a lot of these on there, a range of different prices. But one of the nice things about them is it has enabled people to start to design these types of things, even in places we don't normally think of. And that's the most amazing thing to me. So, how do we win with ARM and Linaro? First of all, we have to make them everyday words. You know, we need to have the ARM inside logo. We need to talk about Linaro. We need to talk about open source. We need to talk about free software all the time. I have 5,000 t-shirts in my collection. I'm always wearing a t-shirt. I'm like a walking bulletin board for free software. And it's very important to me, and that's why I keep talking about it all the time. We need to make ARM and Linaro and the word freedom synonymous. I didn't say the word free. I mean, it's okay to charge for your software, to charge for your hardware, to charge for your time. It's okay. Even Richard Stallman agrees with that. But you should have freedom of choice. You should have the freedom to get information easily, cheaply. And you should have the freedom to use that for any purpose. We need to establish a community of these people and make them think ARM and Linaro all the time. We need to make it easier, Wookie. I'm saying Wookie because Wookie helped me out the past couple weeks in making the ability to port, to use QEMU easier to use for porting applications to ARM64. You know, I was finding it was very difficult for people to do cross-compiling and things like that when they weren't used to doing it. It was difficult for them to be able to really start to use the ARM processors as opposed to what they were used to with Intel Linux. Boot your CD-ROM and it starts up. We need to make sure that the information that they need is easy to find and as inexpensive as possible. I note that some of the assembly language books to teach about ARM assembly language are in the price range of $80 a piece. Down in Latin America, this is a lot of money. And they're all in English, of course. And a lot of these people don't speak English as a first language. Mandarin is the most spoken language in the world natively, and Spanish is a close second. But if you look at the assembly language book for the Raspberry Pi, it's $18, much more affordable for somebody. So once again, Wookie, thank you for your help. We need to encourage projects. We need to encourage entrepreneurship. We need to recognize the people that have done amazing things, especially these kids, especially the people in the universities, and to be able to point them out and make them feel that they've done something good. We should have contests and prizes, and these prizes are perfectly acceptable to have as vendor boards of the different companies that are here. These people are more interested in having new ARM products and new SoCs and new things to program than they would any other type of prize, believe me. And we should be publishing user projects that are open. One of the things that make the Raspberry Pi so successful is that on their site, they have the ability of their customers, of their users, to publish what they've done with the Raspberry Pi. And this just excites other people and creates more sales of Raspberry Pis. Oops. I would like to see a guided development of an entire university curriculum using ARM and free software. Now, I'm lucky enough to be working with the country of Guam, a tiny little island just north of Brazil. And they would like to put together an entire computer engineering course using free software. If I am finally able to engage with them in doing that, this would be a nice thing to be able to use real ARM processors and boards to be able to teach step by step. Now, I taught at the college level for 3.5 years. And like everybody else in the world, professors are busy. And the easier you make it for them to be able to teach a course, whatever course it is, the more likely they are to use your equipment, to use your materials, and teach what you'd like to see them teach. It isn't that we're telling them, don't teach about other processors, don't teach about other architectures, but if you make it easy for somebody to do something, they're more likely to do it. And we can rely on the Raspberry Pi teaching things down at the even lower levels. I don't know if you all know it, you probably do, that the Raspberry Pi Foundation recently announced a 4-core Raspberry Pi using the ARM v7 architecture. I would hope that that would be something that we could point to as being compatible and upward going to the new ARM v8. We need to make real relationships with both major and second-tier universities, research universities. I differentiate between research universities and educational universities, although I would like to see educational universities included. The research universities are the ones who really do the types of cutting-edge research that we'd like to see. And I can tell you that we have a good position here. We have a very good position because they know that trying to do research with closed source is difficult. Back in 1992, Digital Equipment Corporation created a 64-bit version of Windows NT. We offered it to Microsoft for free. Microsoft rejected the offer because they said it would destabilize their operating system for the people who were still on 32-bit Intel products. We also created a clustering system because VAX VMS had a very good clustering system, and we offered it to Microsoft. They rejected it because they said, well, we have our own clustering system. What did they call it? They called it Tiger or something like that, but all I remember was that it was the only time I ever saw two CPUs run slower than one. The thing is, you could do research, even if you got access to the source code for the operating system of Microsoft, and I'm using Microsoft as only an example. Even after you do the research, you can't publish the source code of what you have because it's intertwined with what they have. And so the only thing you can do is write white papers talking about what you did with block diagrams, and this is not as efficient as simply taking the source code and handing it to somebody else who's trying to help you with that research and say, go ahead. So we have a very good position that we have. We have a chip which has extremely good capabilities, along with an open operating system to be able to go ahead and do research. And Linux isn't the only operating system. There's other ones out there like TinyOS and the BSDs. I know it sounds strange for the president of Linux International to be talking about the BSDs, but they are not our competitor. The BSDs have a lot of good things going for them. And if we, as a hardware system vendor, can make available the programming interfaces of the hardware, can make available the boards, they will port to them. And they will benefit from them also. And you, as vendors, will sell more hardware. We also need to take a look at projects like this one from the University of Sao Paulo, San Carlos, where they created a smaller, happier, friendlier kernel. One that was based on Linux, but is only 6,000 lines. So a student could get their grasp around how a kernel like that works. Does it support every device under the sun? Obviously not. But it's a very nice system, and almost every line has a comment on it, which I took from George this morning. There was a friend of mine named John Lyons of the University of South Wales. Back many years ago, about 30 years ago now, he wrote a book which was called The Commentary on the Unix 6 Kernel of Systems. And he commented every single line of the kernel, and then in a separate book made commentary on why that particular piece of code was written that way. This became the most photocopied book of all time, next to the Bible. He didn't get to publish it for over 20 years because AT&T changed their source code licensing agreement. And 20 years later, SCO finally gave him the permission to print the book. But so many people copied that book and handed it out and treasured that book because it showed people how the code worked. And this is another advantage to open source. We have an opportunity to lead the industry in making a secure operating system from the ground up. A truly secure boot, a truly observable, secure operating system, and particularly with a processor that doesn't include microcode, a processor that you can look at every instruction. We could build a community, and I think we are building a community, by allowing people to have a place to blog about things, to talk about things, user forums, user groups, perhaps create a speakers bureau of some of you who would like to go out and speak at conferences, and user groups and conferences, a place to come to get people to talk about really interesting topics. I know I used to run the Greater New Hampshire Linux Users Group for a long time, and one of the problems we had was finding really good speakers. we didn't know who was traveling through Boston, who was traveling through New Hampshire, we could have grabbed them and asked them, please come and give us a talk about what you're doing. We could have people act as mentors for different universities. This is a lot of fun, working with the students, working with some of the professors and what they're doing. We need to constantly publish papers and constantly keep Linaro and ARM in the forefront. We need to have a community store for signature items. I was at a campus party down in Sao Paulo last week, and as I was leaving, people asked me, where can I buy my Linaro shirt? And I said, well, I'm sorry, I don't have any Linaro shirts to sell. Oh, they would like to have them. And we could partner with other companies like Adafruit to be able to have a whole ecosystem created for the new 96 boards. Now, I've been working on a side project for the last several months. And the side project is actually right here. I'll pick it up. I'll show it to you. I'll put it over here so maybe the camera can see it. This is my supercomputer. My supercomputer is made up of an 8-port gigabit switch on the bottom with two 1 terabyte disk drives that I got out of an old notebook computer. And I have a small tower of banana pies, which are an ARM 7 based system. So they have 2 cores. And so together I have 12 cores of computing power, 32-bit. I have 6 HDMI drives, or 6 HDMI ports. I have 6 gigabytes of RAM, and I have infrared on the board, and I have 2 terabytes of SATA, and it only uses about 70 watts. Plus, it all fits inside of my little briefcase, along with my portable keyboard and a LCD projector that will project a 10-foot wide screen. Now, like I said, I saw George's announcement today, and it says, this is interesting as it is, because I can program this with MPI and do message passing interface and do programming like high performance computing. I can program it so that it is a highly available computer. I can program it for heterogeneous computing because sooner or later Windows 10 will be running on this board. And I could have all sorts of BSD or Linux systems running on the rest of these. I can do heterogeneous systems administration because I can set these 2 disks up as a RAID array, and I can also put different systems on here and use one of them to control all the systems. It's very portable because I can put it in my briefcase, and it's very modular because I can replace any one of these CPUs with a different CPU, perhaps one of the ones that are made by one of your companies. Now, the prototype of this, because I had to keep doing things, I made all of this out of very expensive acrylic because it looks nice. So the prototype was about $500 US, but if I made it of less expensive materials than the acrylic, maybe even wood, I could reduce the price by about $100 to make it less than $400 US. Now, they announced the new Raspberry Pi having 4 cores, ARM 7, so I could replace all of the banana pies with that. And that would increase up to 20 ARM v7 cores in this. But today's announcement made this even more interesting because now I can combine 32-bit with 64-bit computing I can have truly heterogeneous computing between the 32 and 64-bit systems, and still have it very portable and modular. I have a suggested configuration of perhaps one Raspberry Pi on top, having about 4 of the new 96 boards in the middle, and 2 Banana Pis at the bottom right now, simply to control the SATA drives, and then use these in all sorts of heterogeneous computing. Estimated cost of that would be $809 US altogether. And I think that it would be nice that when I publish how to cut these boards, where to drill the holes for the disk drives and everything, that we'd be able to figure out how to put those 96 boards into this stack and be able to have the people order these in large quantities for universities to teach their students. And we can make the stack even more interesting by putting in already existing 32-bit systems such as the BeagleBone and others that are manufactured. Now, what should we not do? And I've seen this already in the announcement. I made an announcement on my Facebook page when George talked about the 96 board program. I took pictures of him, whipped it into a Facebook article, and sent it out. Within moments, I had several likes on an article. Moments later, I had 5 people share that to their Facebook pages. I had comments like, I want to buy 2 of those right away. Within moments, I mean literally within 10 minutes, I had all these comments and things. But I did have 2 bad comments. One said, you're comparing a $35 Raspberry Pi with a $130, I don't know where you got the $130 from, it was $129 board. And I said, no, I'm not. I said that they were compatible. I said they were complementary. I said it makes a very nice package. But the other thing was, somebody said, but you're using a GPU that has a closed source driver. And I don't know if that's true. It is. We have to fix it, somehow. We have to fix it. And we also need some courseware in microcontroller to 64-bit. The Internet of Things is calling to us, and we need to be able to capture that. So, why am I interested in free software? I've been in computers now since 1969. This is, I think, my 46th year in writing programs and working with computers. And when I got into open source, I started to see something. I started to see people become visible. People who have been invisible behind the walls of companies, writing code for companies like Microsoft and Oracle, and they were in effect invisible. But with free software, you become visible again. The people that are actually doing the work, doing the good code and stuff, you can see what they're doing. And I looked at all of those kids that were on that front slide. I call them kids, they're kids to me, although some of them are now 40 years old. And I look at these kids and I say, I'm trying to find the next Albert Einstein of computer science. And I'm not so egotistical to think that they're going to come from the United States. They could come from India, they could come from China, they could come from South America, or even as unlikely a place as Helsinki, Finland. But I know one thing, with free software, we'll be able to find them. And just like cream rises to the top of milk and you skim it off, we'll be able to skim those people off. And we'll be able to solve problems we've never been able to solve before. So that's the end of my talk. I will admit that this is still, in order to make this completely working, I have to add my power supplies, which I have, and I have to add a whole bunch of Ethernet cables, which I also have. But it would have taken me too long to plug those in for you, so it does work though. And with that, are there any questions? We have a microphone. Any comments? Now it doesn't have to be a question, just a comment.
I was curious what you meant when you talked about having a system which is secure from the ground up. By that, do you mean something which is secure against outside viral attack or something like that? Or are you talking about a secure boot to allow only signed code or something like that?
I'm talking about something secure from the NSA.
Wow.
You see, I come from a strange country, okay? We have a whole bunch of people in my country that don't think anything at all about putting software from certain closed source companies into their planes and their tanks and stuff like that. But if you are in charge of the Chinese Army or the Chinese Navy, you may think twice, particularly lately, about putting something closed source into your airplanes and your tanks and stuff like that. But unfortunately, even if you had all of the source code of Microsoft Windows, for example, or Microsoft NT, you still can't be sure because you need to have the source code for the compilers and look through that too. And then you can't be sure because you have to have the build system of the source code for the compilers, because it could be that the Trojan horse is in the build code of the system.
So you're talking about having devices where you can verify that they are operating in your best interest as opposed to being agents for some other external entity which may not be operating in your best interest.
Absolutely. And there are countries that are very, very interested in this. So, with ARM architecture, ARM could license out to somebody to make a truly secure CPU that would be verifiable that this CPU did not have a Trojan horse in its microcode. And then go ahead with all the rest of the sources and code that goes into that. By the way, I would like to also give a little story when it comes to proprietary code, how good it is, and what the community can do. In the early days of the Alpha 64-bit port, Digital Equipment Corporation had an extremely good math library that was written for digital Unix and was included with our system. We had paid a mathematician to do a lot of work to make this math library one of the fastest, or the fastest, in the world. And the Linux community wanted us to donate the source code for this math library to the Linux project so that they too could have a fully source code compatible math library. And my company refused because they said we put so much work into it, so much money into it. If we gave out the source code, Sun Microsystems would just copy it, we would lose our advantage. And I was being beaten up about this right and left until finally one day I sent out a mail message to the Alpha Linux team and I said, if you guys think you're such great programmers, why don't you write a better math library? And there was silence on the internet. Until about a week later, a message came across that said, sine is now 3% faster. Next couple days, cosine is now 1.5% faster. And subroutine by subroutine by subroutine down the math library, they made every single subroutine in the math library faster except one. And I forget which one it was. But the reason that one never got any faster was because nobody used it. Nobody cared, and it was fast enough. So this is a type of thing. If you make it, if you allow them to be able to do the work, they will do the work. You don't even need to give them the firmware for the GPU. Just tell them what the hardware does, and they'll rewrite the firmware. Maybe they'll even make it better. Yes, sir. Wookie has a observation or question or something. Wookie over here.
Yeah, I was interested in your suggestion about speakers wandering around the world, list of things I thought was interesting. I mean, I'm happy to do that, but is there a place someone already collects this information, or do we have to make one? Do you have a plan?
I think Steve was taking notes when I mentioned it, so I think he now has a plan.
Fair enough.
And one of the other things I like to say is, I don't know how much, I mean, I know that Linaro has been talking about a university program of some type, or engaging universities. And I think that the first step of that should be to ask universities what they would like to see in a university program. To say, what do you need? What would best help you in a university program from Linaro and ARM? And the vendor companies. I mean, I know a lot of the vendor companies have university programs themselves, but you don't have to do everything yourself. And your university program could benefit from some of the things that a Linaro university program could do. You could use it to amplify what you're doing today.
By the way, ARM has a university program where they provide lab in a box, and Qualcomm is planning to participate in that. I'm from Qualcomm, and we are planning to participate in that with our boards.
Maddog is actually going to be in the UK for the first week or two of March. Sorry, Maddog will be in the UK for the first couple of weeks of March, and we'll be meeting Khaled at ARM to talk about that as well. But one of the things that is interesting for the universities is if all of the vendors wanted to interface with them, the universities would just go crazy. So they just don't have the bandwidth to do that. So whoever gets in first, or whoever's got the historical relationship, has a leg up. There's a possibility that a place like Linaro could help simplify that with a single interface, and enable a pipeline of stuff to get into the universities with supporting software and things that is compatible across multiple platforms. So that's an interesting area.
But there's also an opposite of that, and there's the fact that companies don't have unlimited resources either. So there's a limited number of universities that you can interact with, and you could use a Linaro university program to help you access universities that you don't have time or resources to access.
That's the reason we are participating in ARM's program instead of doing things on our own completely. So we'll rely on them and their relationship.
Anybody else? I'd also like to make one more statement. This may not be very popular, but when I came to Linaro about a year and a half ago now, I was thrust into the ARM embedded system ecosystem. And believe me, it was interesting. There's the Chinese proverb, may you live in interesting times. It was interesting, okay? Because I was hit with all these terms like Cortex this and Cortex that, and and it wasn't just boot this ISO off the CD and you're running a live file system. It was take this portion here and put this here, and using boot systems I'd never even heard of before. I was Grub and Lilo, right? And maybe Milo for the alpha, and there's all these other boot systems. It's hard. It's hard for somebody to get started into the ARM architecture. And I think what we need is kind of like ARM for dummies. And maybe ARM for Dummies for managers too, to explain to them why should they be interested in an ARM architecture as opposed to the one they hear about all the time. And I think that would help. There's a thing.
You know, you just pick a distribution, flash it on a card, it's done. It's easier than burn a disk, put that in, blah, blah, blah.
So yeah, as of last
You do have to pick a distro.
you can stick a bog standard Debian ARM installer on a Juno board and it boots. So we are getting there. I think we're nearly there, in fact, after a great deal of aggravation to fix all this.
Yeah, that's on a Juno board, but if you pick one of these other boards,
Most of them are supported now.
96 boards next week.
I think having the standard method, the standard architecture will help out a lot as people adapt to that.
Two questions. One is there an interest, you talk a lot about universities, is there an interest within Linaro to create a university working group where you could allow interested universities to come in and participate in driving the ARM ecosystem, obviously under a different working model than the commercial entities, but that might be something.
I think that the Linaro management has been thinking about that, talking about that for some time, but like it was mentioned today, it's been a lot of things that have happened in only 5 years. And as the organization grows and they get more resources and everything, it becomes a lot easier to do that. But I think there is an interest in that, and Steve's nodding his head, so yes.
Cool. And I guess the other one about the Linux, the Linaro or ARM for Dummies, and like, oh, Debian's just going to work now, or I'm part of ARM. I see the monthly engineering reports that come through under confidential. I see all the great work that's either ongoing or popping out. Where is that published easily publicly for everybody that isn't a member of Linaro, be it a university person or just anybody out there that wants to learn more? I mean, I see it under confidentially, but I don't see that central site that says, here's all the good stuff that's going on being upstreamed, and hey, it just works, or go get it here. Is that something that Linaro is going to work on, or who's driving that for the overall ecosystem, that public view?
Here's another thing that I think that a lot of companies need to understand, and maybe ARM also needs to understand, is I saw a very powerful letter one time. It was in the early days of Linux, and I was asked to go to Austin, Texas, to IBM's site. And before I went there, being an engineer and trying to get something that you'd worked on, even on your own time, made to be open source at digital, was like walking a gauntlet, by having people beat you and stuff with, caning and stuff like this. I mean, it was horrible. And most of the time, after the engineer got finished doing that, they said, never again, I'm never going to do it. And the same thing was true of IBM. But I went to this IBM meeting, and I talked to them about open source, this large group of people, and they said, please, Mr. Hall, could you go into this room? We're about to have a closed meeting, and you can't, you shouldn't be looking at it. And so I went in the little room, but after a while I had to go to the bathroom, so I came out of the room and happened to look up on this projected screen, and there was a letter from Lou Gershner that said, in the past, IBM has been a closed source company unless somebody has made a business case for us to be open. From now on, we're going to be an open source company unless somebody makes a business case for us to be closed. And that, I looked at that and went, oh my God, that is the most powerful letter I've ever seen, because he turned the whole thing around. Now it was based on the product manager, the business person, to say, yes, we have to keep this closed because it's worth some money. But if he couldn't prove that, then they would open it up. And this allowed a lot of engineers to do a lot of things that helped a lot of customers. I think that is definitely the way. I was a product manager at Digital back in the early days of the X Windows system. I had an engineer out in California who refused to publish the source code for the dumb frame buffer version of the X server because he said it made our X server so much faster than everybody else's. We were losing millions of dollars of sales because we wouldn't publish the source code for that. You know, government agencies, private companies, they would not buy our product. So I flew out there to see him. I said, what is so special about your X server? Oh, look at this algorithm here. This is really, really good. I said, nobody else, none of our competitors have that? Oh yeah, IBM and HP do. Well, what else? Well, look at this here. This is really good. Nobody else has that? Well, actually, that came out in MIT's X server last week. It finally came down to this one tiny little algorithm that allowed him to do Mandelbrot's faster than anybody else in the world or something like that. I said, how many people do that? He goes, well, hardly anybody. So we're losing millions of dollars of sales because of this Mandelbrot accelerator. He said, okay, publish the source code. Sometimes we get caught up in what we think is very valuable, but it's actually causing us to lose a lot of business. That's a problem. Anybody else? Comments? By the way, I found another company one time that didn't publish the source code for their firmware because in the source code for their firmware were all these comments about their own suppliers that were rather nasty. We actually had to get a third party under non-disclosure to clean up their comments before they would publish them. Yes, sir.
Yeah, maddog, I mean, you were talking about being able to mix things. I was actually having a private conversation earlier around firmware, because one thing that pleased me with the 96 board was looking at a lot of the standards and some of the ARM firmware stuff, and this isn't to make it proprietary, this is to push it out there and do a lot of cleanup on the 64-bit code. And we were actually saying, well, there's no reason why that firmware couldn't be built for V7. And specifically we said V7, because then it could run on all the same V7 boards. It could run on a V8 board booting it as 32-bit, because you don't really need those few extra instructions in your firmware.
Mm-hmm.
And try to help unify V7 to V8 world. And again, not something that ARM needs to do. The code's up in a Git repository. Somebody else could go and start doing it. And then clean up all the other boot mechanisms and everything else and run it on top of it.
Sure, and to get it that far there, and then you say to people, how else can you change this? How else can you do other things? And to let their ideas to come in, because it's boot firmware, right? You know? And you want it to be if you can make one SD card that could then fit into each one of these boards, that's a lot nicer than having to say, well, this SD card has to go in here and this SD card has to go in there and this. It's a lot easier. And easy is what wins.
And the fact as well that with the whole IoT thing, you've got 8 and 16-bit machines growing up to 32-bit, as well as 64 bits going down. I mean, 4 gigabyte address spaces is going to satisfy a lot of problems for a long time.
Well, it's like I said in my previous slide. Oops, wait a minute. No. Oh, yeah. Microcontroller to 64-bit. I meant that. You know, to use it, to present them all together as a family of chips, as a family of architectures that can do everything is a big plus. Yes, sir.
Fail. So, as you said, we badly need to free up the graphics drivers, and Linaro's been hiding from this problem for 5 years because none of their members are terribly interested in doing it. And a lot of the reverse engineering on Mali has been done, but it's not published because the man who's done it's very tiresome. And ARM's not going to do it because they're scared of pants. So how are we going to make this happen? To be fair, Broadcom have done some. Broadcom Snapdragons have fixed mostly, and some other chips. So we might just get some different 96 boards which have a free driver, and then we can ignore this one.
What happened to Lima?
So yeah, well, so that's Luke being a pain in the arse. So he turns out he published the instruction set stream reverse engineering, but he didn't actually publish any code that the rest of us who aren't GPU gurus can. So there isn't something you can just compile. There's a whole load of here's what I worked out, and he claims to have some code, but he won't publish the thing. So so we're a bit stuck there. So a lot of work has been done around that, but there's still no actual code we can use yet. And somebody could do that work if we provided some resource, which we have lots of resource here. There are people around here who could do that.
I have a university called the University of Sao Paulo in Brazil. They have 100,000 students and they have 16,000 PhDs. They are perfectly willing and ready to actually build their own GPU. Now, if you provided them with one and the information under non-disclosure, so they could then take and write the source code for the firmware, for the driver, I'm sure they would be happy to do it.
I'm not sure any of our members are going to give them a GPU with the instructions. Somebody has to reverse engineer it, and quite a lot of that's been done. So maybe we can just get them to use Luke's published info to write a bloody driver. That would be a useful start.
Well, talk to me, and let's see if we can get it done.
So Qualcomm processor doesn't use Mali, it uses Adreno, and there is a Freedreno project by Rob Clark which provides the open source GPU drivers for Adreno processor. So yeah, that's a good initiative.
The one thing I forgot to say, of course, the Raspberry Pi driver is not free either, just to be clear. All they've done is publish an API to their binary driver running on the video core. So they can pretend to be free, which is useful, but it's still cheating.
Well, this actually brings up another subject.
That's not actually up to date. I believe they have actually published the complete open source stuff. It's just not ready in Mesa yet. But they've demonstrated Quake with completely open source.
So I'm getting the cutoff message from Steve, but one more thought I'd like to have. ARM designs other chips other than just CPUs and graphics chips. I believe they design FPGAs and digital signal processing chips. And these would be other things that would be very nice to get out of the university program to see how they could be utilized in a general purpose computing system. So that's just another thought. Thank you.